In our last video, we talked about what a proportional relationship was and how to identify it in a table. In this video, we're going to talk about graphing proportional relationships, or we want to answer the question, what does a proportional relationship look like on a graph? So again, we're continuing to develop this idea of tables, equations, and graphs, and connecting those concepts together when it comes to relationships between two things. So this video is going to focus on the graph. What does it look like when you graph the table of a proportional relationship? So here on the screen, I've got two relationships. One of them is proportional and the other one is not. And we're going to kind of compare and contrast them. So on the left, I've got hours and dollars, and this is a proportional relationship. If you find the unit rate here each time, you're going to find that it has a constant unit rate of $5 per hour. On the right, this relationship is not a proportional relationship. If you find the unit rate here, dollars per hour, it's always changing. It's never the same. So what is different about these graphs and what's the same? Well, if we're looking at them, I see that they both have a straight line in common. So I'm not really sure what that tells me about a proportional or non-proportional relationship here. They're both got the same straight line. So what else is different about them? Straight line and straight line. Now, you might not notice, but if you look carefully, the one on the left passes through the origin, through 0, 0. And the one on the right does not. Not through the origin. So that's something that makes a proportional relationship unique, is it does pass through the origin and it's also a straight line. Now, if we scroll down, we're going to see two more relationships where one is proportional and the other is not. The one on the left is a proportional relationship that has a constant rate of 60 miles per hour, and the one on the right does not have a constant ratio. So again, comparing the graphs here of these two, we'll notice that again, the one on the left is a straight line, and the one on the right is not a straight line. But they both pass through the origin. So in order for a graph of a relationship to be proportional, it's going to have both of these qualities at the same time. You'll notice the first one was a straight line, went through the origin, and the second one was a straight line that went through the origin. And then the non-proportional ones had one of them, but not the other. So we have to have both present in order to call a relationship proportional on a graph. So here it is. The graph of a proportional relationship will always be a straight line, and it will always pass through the origin, or 0, 0. So very easy to tell from a glance or a graph whether something is proportional or not. So let's take a look at a couple of examples here and determine if they are proportional or not just by looking at their graphs. So I give the table again just to kind of reinforce the idea that we've got tables and graphs here in these relationships. Now, one of these is proportional and one of them is not. And hopefully looking at the graphs, you can immediately tell which one is and which one isn't. Now, if we were looking at the tables, it would probably take you a little bit longer to figure that out. Thankfully, looking at a graph, we can tell right away. The one on the left is proportional. This is a proportional relationship, because if you look at the graph, it goes through the origin and it is a straight line. And then we can back that up again in the table, and you can see that every time here we have a ratio of 5 meters per second. 5 meters per second. That's a constant rate or a constant ratio there, not including 0, 0, because 0 divided by 0 is undefined, so we won't look at that one. The one on the right is non-proportional because it is a straight line, but it does not go through the origin. Okay, does not go through the origin, so this is not proportional. And again, we can back that up. Looking in the table, we've got 18 centimeters per hour. This is 8 centimeters per hour. This is 4 2/3 centimeters per hour, I believe, and that is 3 centimeters per hour. So from the table and from the graph, we can kind of confirm 2 times that this is not a proportional relationship, but by far it was much easier to tell if it was proportional or not from the graph. So determine whether the cost is proportional to the number of items in each relationship by graphing it on the coordinate plane. So here we've got 2 tables. And now we're going to look at the graphs of these items to see if they are proportional. So graphing the number of tickets and the cost, 2 tickets cost $6, and that's here. 4 tickets cost $8, 6 tickets cost $10, 8 tickets is $12, and 10 tickets is $14. Now this is a straight line relationship, so if I kind of extend that, extend that straight line back, that is not going to cross at the origin. So this is non-proportional because it does not pass through the origin. And again, we can double check that by looking at the ratios here of the cost per ticket. Here is $3 per ticket. This is $2 per ticket. This is 1 2/3 per ticket. This is $1.50 per ticket. And this is 1 2/5 per ticket. So again, we can see from the table that this does not have a constant rate of change or a constant of proportionality. Looking at the next one, here we're comparing the number of hot dogs to the cost. 2 hot dogs cost $6. 4 hot dogs are $12. 6 hot dogs are $18. 8 hot dogs are $24, and 10 hot dogs are $30. Again, this is a straight line, and if we very carefully, of course I would be using a ruler if I was on paper here, this does pass through the origin and it is a straight line. This is proportional. From the graph we can tell that, but we'll just confirm that here. $3 per hot dog, $3, $3, $3, $3 per hot dog. So that has a constant rate of change there, and we can confirm that in the graph and on the table. So when 2 quantities are proportional, any point on the graph can be used to find the constant of proportionality, to find the unit rate. So for any point on our graph, any x and y coordinates, the constant of proportionality or the unit rate will always be y divided by x. Y divided by x will always tell us our unit rate for any graph. So we can use any point on the graph to find what the constant of proportionality is or the unit rate. So here Keith plants a seed. Every 3 days after the seed sprouts, he measures the height of the plant. The graph shows the results. It says, find and interpret the constant of proportionality. And we can easily tell from the graph that this is a proportional relationship. It starts at 0, 0, and it is a straight line. So if we're trying to find the constant of proportionality or our unit rate, we can actually use any of these points on the graph. So if I take just a point like 918, and I take y divided by x, that gives me 2, and I only need to do 1, but I'll just show you. If I did the other ones, 12 divided by 6 is 2, 6 divided by 3 is 2, so you see we always get that constant of proportionality, that constant unit rate, and we were asked to interpret that. What does the 2 mean? So it's the y value, height, divided by the x value, day, so it's millimeters per day. So our constant of proportionality is 2 millimeters per day. So this plant is growing at a constant rate of 2 millimeters per day. Then we were asked to explain what the points 0, 0, 1, 2, and 6, 12 represent or mean. What does 0, 0 tell us about the plant and its growth? Well, 0, the x value is 0 days, and the y value 0 is the height in millimeters. So that means it grew 0 millimeters in 0 days. And what does 1, 2 tell us? Again, 1 is the number of days and 2 is the number of millimeters. So that tells us it grew 2 millimeters in 1 day, because it's growing 2 millimeters per day. And then finally, what does 6, 12 tell us? Well, 6 is the number of days and 12 is the number of millimeters. So that tells us it grew 12 millimeters in 6 days. That's interpreting the ordered pairs on our graph. So graphs of graphs of proportional relationships are straight lines that go through the origin, and we can use any ordered pair on the line to find that constant of proportionality, that unit rate, that constant rate of change.